Hello, Namaste, welcome to Story Optimizer. Learning like a child is what first step to deep learning. Think of a child learning to tell a cat from a dog. At first, you show the child a picture of a cat and you say the word cat. Then you show a picture of a dog and say dog. The child looks and listens and at first might get them mixed up. They might see a fluffy dog and call it a cat. You gently correct them. No, that one is a dog. Bit by bit, after seeing many different pictures, the child starts to understand. They learn to spot the patterns, the pointy ears of a cat, the long snout of a dog, the different shapes and sizes. This is very much like how deep learning works. Deep learning lets computers learn from examples. Instead of rules, we show it a lot of data, images, sounds, or text. Just like the child, it makes a guess. Is this a cat? Early on, guesses are often wrong, but each guess gets a little bit of feedback. It learns from its mistakes. Think about this process like a ladder. First, you notice simple blocks, their colors and shapes, then walls, then rooms, and finally a house. Each step builds on the last. Neural networks are built the same way, with layers like rungs. Early layers find edges and colors. Next layers form shapes like eyes or a nose. And the top layer recognizes a person. Section 2. The ladder of ideas, how neural networks work. Let's climb our analogy ladder a bit higher. Think of a neural network like our school system. A child starts in first grade. In first grade, they learn basics, letters and numbers. Next grade, letters form words. Then words build sentences. Each grade is a layer of learning, building on the last. You can't write essays in 10th grade without the alphabet. Neural layers work the same way. Each handles a more abstract part of the task. The data we give the computer is like lessons. The more lessons and examples, the more it learns. To recognize your voice, a model needs many examples of you speaking. Data is the food the model needs to grow. Without lots of high quality data, it can't learn well. It is hungry for examples. Training is the learning process, like practicing for a test or a game. Solve, check, fix, and try again. The same cycle a neural network follows. Section 3. Practice makes perfect. Training a deep learning model. Let's make it concrete. A system that turns your speech into text, speech recognition. We need a huge amount of data, many thousands of hours of recordings. Crucially, each audio clip needs a perfect transcript, the correct answer. We feed clips into an untrained network like a baby that doesn't understand language. It might hear hello, how are you, and output gibberish like blue door run fast. We compare to the transcript, compute a big error, and send feedback back through the layers. The network makes tiny adjustments, nudging its output closer to the right answer. Then we repeat with the next clip and the next, millions of times. With each cycle, it gets a little better. This takes lots of compute and lots of time. Like a musician practicing scales. Many wrong notes at first, then smoother and more accurate over time. It learns patterns, what a T sounds like versus a D, and that is far more common than thistle. But if training data has only one accent, the model will fail on others. The model is only as good and as fair as its data. You might be surprised how often you already use deep learning every day. It's not just futuristic, it's woven into our digital lives. When you unlock your phone with your face, a model trained on your images recognizes unique patterns. Translation apps map words across languages by learning from millions of translated pages. Music services learn your tastes and suggest new tracks with similar patterns. Video platforms blend your history with millions of others to personalize recommendations. In medicine, deep learning helps read X-rays and MRIs. Trained on thousands of scans with and without cancer, it can spot subtle patterns, even hard to see ones. It doesn't replace doctors, it assists them catching issues earlier. From real-time traffic to spam filtering, it works quietly in the background. It helps farmers monitor crops from satellite images. It helps banks spot unusual spending patterns. Together, these show a general purpose tool for recognizing patterns in large data across nearly every industry. It touches almost every aspect of modern life. Now let's climb to the very top rung of our analogy ladder. Deep learning isn't an artificial brain, but a powerful, smart helper. Imagine an assistant that can read a million books in a second. It doesn't think for itself or understand love or justice, but ask it to find and summarize patterns, it can do that instantly. It can see patterns in complex financial data. It can accelerate scientific discoveries. But it has no judgment, it only knows what it's trained on. Like any powerful tool, it can be used for good or harm. We are the ones who hold the ladder. We must choose clean, accurate data, check for biases, and ensure models are fair to everyone. Build systems to test for safety and reliability, especially for critical tasks like driving or diagnosing disease. We must provide the wisdom, the ethics, the care. The story of deep learning is just beginning. It learns like a child, builds ideas in layers, and practices until it gets it right. For more such informational videos, make sure to like and subscribe Story Optimizer. Thank you.